Okay, this first problem on 2.2b is actually the same as the homework problem, except that this time we're doing it algebraically. And this is the kind of stuff we were doing towards the end of the year last year in pre-calc. We're looking at the limit as x approaches 0. And the trick for square roots was that we multiply by the conjugate of the top. So I like to put parentheses just to sort of emphasize what we're doing. On the last homework, we didn't have the parentheses, but they were separate fractions. So conjugate changes the sign outside the square root sign. So top and bottom. So make sure that you're changing the sign. On the top, the square root cancels. The inner and outer terms cancel, and then foiling you have minus 1. It always ends up being minus. So, we should write limit as x approaches 0. We're mucking up the denominator, but in a way that doesn't cause division by 0. And it never helps to distribute on the denominator. So I'll write that in blue. We're only trying to fix the top so that we can do some canceling. So, oh, look, we can cancel the 1s. And now we can cancel the x to the 4ths. And as soon as you have factored, canceled, you plug back in. So I'll write that down. Maybe I'll write it in green. Why do I say plug back? Because the first time you plug, you get 0 over 0. So now what are we plugging in? Oh yeah, 0 for x. So we don't need to write the word limit anymore because we don't have a problem. So 0 to the 4th plus 1 plus 1. And it is 1/2, which is 0.5. By George. Okay. Looking at some of the weird things that happened in the notes, we have some very, very small numbers. So you can actually type this one into your calculator. You get 0.000000001. So here's the trick to these without making yourself crazy. This is 10 to the negative 4, and this is 10 to the negative 8. So two things. If you put the 0 in front, you can count the number of zeros. And then also notice that 4 zeros before squaring doubles. So squaring doubles the number of zeros. What do you think cubing does? Yes, cubing triples. because the number of zeros is the power of 10. So we start with 10 to the negative 4, and then we want to have 10 to the negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. Fine. Sorry, the page keeps moving when I accidentally grab it with the bottom of my hand. Okay, so what is this going to be? 4 sets of 4 zeros. Fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 zeros. Wasn't that special. So if you try it on the calculator, it just gives exponential notation. And if you try 1 plus that, it can't display it. And that's one of the problems with problem 9 on the homework is. So I'll write a little note. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It just thinks it's the number 1. So that's why it gets round off error. It can't deal with that much precision. And so problem 9 on the homework is actually messing around with that. So a little thing to notice, that a function is continuous Okay, if f of a and the limit are equal, what the heck does that mean? Let's think about a picture. If I'm looking at f of x, continuous means the value of the function, which I'll do in blue, and the limit, which I'll do in green, match height-wise. Okay, so what that means is the continuity is, if it's just passing through, you can just calculate it. So we'll just do 2 to the 3.5. Since the limit is the same as f of a, we can just figure out what f of a is. Okay, so calculator says that's 12.114. And the moral of the story is always just plug the number in first. Okay. What's the domain? What is it? Oh yeah, you can't divide by 0. Okay, so what's the domain? The domain, I'm going to just write it the easy way. T not equal to -1. Fine. So G of 3, we can use continuity. So Okay, what happens if we plug in this? -1 squared minus 3 times -1 minus 4 over -1 plus 1 isn't just division by 0, it's 0 over 0. And remember, limit means don't stop. Okay, so we try and factor or cancel. If we're going to do it algebraically, I'll just say or trace nearby, which is what we've been doing for the last, yeah, that was what 2.2a was. Okay, so to do it algebraically, I'm just going to write down what we have here. 3t, sorry. We have to factor and cancel. Don't forget to write the weasel word limits. Limits mean you can cancel things that might be zeros legally. Here's the trick. If the bottom is t plus 1 and that's giving you the problem, one of the factors on the top should be t plus 1. If you have 0, that means t minus a is a factor. So what's the other factor? So t, it must be -4. All right. We factor and cancel the t plus 1s. And we get -1 minus 4, which is -5. Okay, on to back. A few more algebraic messing around. Let's see, what have we got? Okay. Let me write it this way. I'll add the thing. I'll say t. T approaches a. So if t equals a gives me the problem, then t minus a must be the factor. T minus -3 is t plus 3. So let's try t plus 3. Is the other factor. Let's see. 2t must start with 2t and must end with 1. Double check by foiling. Sure enough, that's 2t squared plus t plus 6t is 7t. So that's all good. Let's see. I think I'm going to be factoring out t plus 3 on the top. Is that right? Sure enough, this is a difference of squares, so this one's actually easier. Okay, factor cancel. Plug back in. You don't need the word limit anymore. And we get 6/5, which if we graph and trace nearby, we should get about 1.2. All right. So the trick on this one, of course, is just simplify the top until we can cancel h. Okay, so let's go ahead and do this. Oh, note. Oops, it's 4 plus h. No freshman foiling. Ah, okay. Oops, sorry. Don't forget to factor h out of both terms. And then plug back in. So don't forget, it's not factor cancel, it's factor cancel plug back in. Okay, so let's see. That's a terrible arrow. So divide by 4 plus x by multiplying by 1 over 4 plus x. And I always put it in front so it doesn't get lost. Because the stuff that was on top, that's what ends up being usually the complicated part. Okay, so what do we do with this puppy? The common denominator. Just like on the previous homework. So it's going to be multiply the first fraction by x over x, and the second fraction by 4 over 4. Then write it as a single fraction. My 4s are getting, they look more and more terrible. All right, cancel the x plus 4s. Don't forget, you have to leave a 1 in the top. Factor cancel, plug back in. And we're done. Yay.